Right, guys. Those that work in, you've got to work. Right, so for the rest of us, be able to state the equation of a line given 2 points that are on the line. Now, I've got a set of axes here, but basically what we have to be able to do, if I say to you that 2 coordinates, A and B, lie on a line, and I tell you that point A is at 2, 5, okay? And I tell you that point B is at 5, 11. Right. Just out of interest, would you be able to look at the connection of those 2 coordinates and tell me what you think the equation would be? Yeah? Have a go. What do you think it could be? So it's going to be y equals mx plus c because we're told it's on a straight line. What would you think the connection would be? Is it?
Well, I'd like expand the coordinates, so because there's a difference of, like, there's a run of.
Okay, so you're doing what we're actually going to do, but I'll stop you up because you're kind of going ahead. I'm kind of thinking at the moment, is there any just link? Can you spot a link between the x coordinate to the y coordinate that works for both of them? Is there anything that you can do, like, let's just add 3? So 2 add 3 makes 5, but 5 add 3, no, it doesn't make 11. So it can't be x add 3, for instance. Can you spot what it might be? Times 2 plus 1. Yeah? 2 times 2 is 4, plus 1 makes 5. 5 times 2 is 10, plus 1 makes 11. So I know, really, that it's going to end up being y equals 2x plus 1. Yeah? Now, it's not always that easy to spot that. So what we're going to do is we're going to use our gradient and intercept method. So we know m will be the gradient and c will be the y-intercept. So the first stage is to work out the gradient. Now we know that we've kind of been doing it before. Gradient is rise over run. So how do I work out the rise? Well, I take it from the y coordinates, yeah? So I've got to look at the difference between 11 and 5, right? So I do that by doing, well, 11 subtract 5 equals what? 6. Right? And that's divided by the run. So the run is the difference between the x coordinates. So it would be 5 subtract 2, which makes 3. So I've actually got rise over run 6 over 3, which is 2. Okay? So that enables me to actually fill in the m. So now I've got y equals 2x plus c still. I don't know what the plus is. How? Well, actually, are you all okay with a gradient thing? Yeah. So I've not got the line in front of me. Yeah. Right? Not got the line in front of me, nothing visual. I've done it purely numerically. How do I find the plus c? Is it? We could actually, like, one way is to now have a set of axes and plot them. So do 2, 5. So I've got 2, 5, and I've got 5, 11. Well, that doesn't even fit, so I can't draw it. How could I draw this line if that doesn't fit? Practice skills. So there's obviously a, well, what do you think? 5, 11. I could put 5, I could put 11. Where would be another point I know definitely, do you think? Well, if I know the gradient is 2, I can work out a few other points. Where would they be?
0.
But I can start at this one. What does a gradient of 2 mean? As I go across 1, I have to go up 2. So I could just put a point there, a point there. I could do that, and I could go backwards. So I could go down 2 and across 1, down 2 and across. There you go, look. That is one way of doing it. So it ends up being 2x plus 1. We know that. Makes sense? Yeah. However, that's not the way we want to do it. Don't want to do that. Alright? We need a new, more numerical method. Now what we do know is that this y equals 2x plus c has to give me two things that I know. And it has to give me these two coordinates. So I know that when x is 2, y has to be 5. And when I know x is 5, y has to be 11. So I can kind of use that information. You're catching up. Doesn't look like you are. So I have to use this information, which is, well, if I put it into this look, 5 has to be gained by doing 2 times 2 plus something, plus c. Alright? Now 5 therefore is 4 plus something. So it looks like c is going to be 1. So c would be 1. Now I can trust myself there, or I could check with the other one as well and say 11 must be 2 times 5 plus something, and therefore 11 is 10 plus, so again c is 1. So therefore we know that it's going to be y equals 2x plus 1. So in that way I didn't even have to draw the line. Right. Okay with that, ladies and gents? So let's say I'm going to set you guys a bit of a challenge. Are you listening to this then? I want you to think of your own equation, something x plus something. Be mean, be horrible if you like, use fractions and all sorts, because that's when it gets hard. Maybe starting, come up with one. You then work out two coordinates that you know lie on that line. You then give those two coordinates to your partner and ask them to work out what you started with. What was your equation? Yeah? Okay. So I would start, for instance, if you want to, just a little bit of an explanation. On my bit of paper, I'm going to go, right, I'm going to use y equals 4x minus 9. So I know, well, I'm just going to pick when x is 2, well, y has to be?
Minus 1.
Minus 1. So I could tell my partner, well, the first coordinate is 2, right, minus 1. And then I go, well, x is, if I'm going to be mean, I go, okay, x is minus 5. Then y is minus 29, yeah? So then I go, well, point B is minus 5 minus 29. And I say to my partner, right, they're the two coordinates. Work out my equation. And then they give it back when they've worked it out, and you say yes or no. Got it?
Yep.
If anyone else wants to partake in that, if you fully understand, you go for it. If you want to carry on, I can answer your question. Okay. For those of you that were following on here, alright, now when I did the coordinates, you know, I worked out the difference between the y coordinates and the difference between the x coordinates, the rise over run. There is another way that some people remember it. I'm going to have to start this again. Okay. The way some people remember it is to say, right, well, if I'm working on these two coordinates, right, I would say, instead of A, I would say, well, this is the first coordinate I've got. This is the second coordinate I've got. So what I then have is, well, this is x1, y1, and this is x2, y2. It's just like saying the first x coordinate, the second x coordinate, and then, so a lot of my IB students, for instance, because they like having formulae to look at, they would then call rise over run, it would be, sorry, y2 minus y1 divided by x2 minus x1. So it's no different from just saying work out the difference. Okay? But what it does help you is to remember it's got to be the same order. You can't mix them up. Okay? Right. Do you believe? Can I ask you then, guys?